Okay.
You can hear it, sir. But
Here?
William.
Hello, 1 minute.
wait,
Now
sir.
tell me.
Video slide is there, sir. Sound is not
Ah.
coming.
So that means you're audible.
No, sir.
Okay.
Play the sound, sir. Play the sound.
Only slide is seen. Correct?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now what I'll do? I will only explain. So once again, good morning to everyone, and thanks for some arrangement. But still, what we'll do today? We'll go to the theory part, written part, slide part. So I explain. So I thought I can go with some other method, but anyway, it is difficult. So today we start. I told new chapter. Yesterday I completed the third chapter, modern periodic table and trends on the modern periodic table. Now today, so we are going to discuss the most important, and I told yesterday, fascinating chapter, very interesting chapter, chemical bonding and molecular structure. For this, I have given a caption, the poetry of reality. Okay, so what is happening in real? Okay, so in the form of a poem, poetry is very beautiful. Now you'll enjoy. So poetry. So in English, like that. So in chemistry also, we let's take it as a poetry of what is happening in the real, at the microscopic level. So that's why I have given a small caption. Just it fell to my mind. So it is chemical bonding is nothing but it is the poetry of reality. Okay, right. Now am I audible?
Yes, sir.
Yes, sir.
Very good. Right. So now we'll start the chapter. Okay. Chemistry states the more energy you put into a bond, the harder it is to break. Okay, correct. See, when the energy is used in making a bond, the same amount of energy we require to break the bond also. So that means in chemistry, what we are doing? Making a bond and breaking a bond. Why are making a bond? To make new things. Okay. Then why we are breaking the bond? We don't want that. We want to go to some other form. So we are breaking. So whether we make a new thing, whether we go for the new types of reactions, it is nothing but in a simple sense making and breaking a chemical bond. That is known as what? Chemical bonding or chemistry. The root what principles behind the chemistry is what? It is a making and breaking a bond. That is known as what? Chemical compounds, which comes under the subject chemistry. Okay. And what you want to say here, whenever you are making a chemical bond, how much energy you are supplying? Okay, to make a bond, how much energy involvement is there? If you supply more energy, then with lot of trouble, with lot of effort, with lot of energy, you have made it a bond. Now, to break that bond, for some reason, you have to supply same energy. How much trouble you have taken, same trouble is there to break also. That is the meaning of this caption. So chemistry states the more energy you put into a bond, the harder it is to break. Okay, right. Now let us see next slide. Now let us go for introduction part of one by one. So diamond is very hard while its electrope graphite is very soft. This we learnt. Gases like hydrogen and oxygen are diatomic, while the inert gases are monatomic. They exist as a single, helium single, neon single, whereas hydrogen not as H as H2, oxygen not as O as O2. Okay. So all these, what I am saying, we have seen observations. Okay. Now we will see afterwards what happens. Carbon combines with chlorine to form carbon tetrachloride. which is a liquid and insoluble in water. Next observation. Sodium combines with chlorine to form sodium chloride, hard and brittle, that readily dissolves in water. The possible reason for these observations lies in the type of interaction that exists between the atoms of these molecules, and these interactions are responsible for holding the atoms or ions or the particles together. Okay, right. That means here holding together is very important. With what force they hold. The interatomic attractive forces which hold the constituent atom or ions or particles together in a molecule are called chemical bonds. Now we are concluding what is meant by a chemical bond. A chemical bond is a kind of what? Force. It is a kind of force. What it is doing? It is holding atoms together. It is holding molecules together. It is holding particles together. It is holding ions together. So you can use any word. Particle is a general word. Particle may be an ion or atom or a molecule. If you want to be a particular, then you can use holding ions together, holding atoms together, all those. Otherwise, uh, if you use general word, it holds good for everything. It is a force which holds what? Particles together. That is called what? Chemical bond. Bondage. A bondage between a teacher and a student, a bondage between a son and father, a bondage between father and a mother. Okay, so they are all called emotional and all those psychological bondage is there. But here it is a chemical bonds. Okay, so they are also holding. Their emotions are love, affection, affinity. They are plays very important role in holding together. But here we are holding atoms together. That is called what? Chemical bond, because atoms, molecules, particles, they all come under the chemicals. So holding chemicals is nothing but what? A chemical bond. There is one force. That force is responsible. It may be a cohesive force or it may be any other force which is bringing atoms together, which is holding atoms together to give a particular shape, to give a particular geometry. So all these comes under what? All these comes under chemical bond. Okay, right. Why do atoms combine only in certain combinations to form molecules? For example, oxygen combines with hydrogen to give water, and with carbon it gives carbon dioxide. Problem is not this one. Problem is this one. What? This one problem. The structure of water is V-shaped, while that of carbon dioxide is linear. What difference is there? Both are triatomic. CO2, 3 atoms. H2O, 3 atoms. Both molecules, they have 3 atoms. That's why they are called as triatomic molecule. Though the number is same, why water is V-shape? Why the water is, why this carbon dioxide is linear shape? That again depends on what, how they have combined, in what orientation, in what angle, that matters, no? For example, in the alphabet, there is one word, EAT, eat. The same English alphabets, I will make it here and there, TEAT. It is also triatomic word, no? Try 3 alphabets I am using and making one word. So, but meaning is different. EAT, TEA, ATE. With the same 3 alphabets, I have made 3 different meanings. Like that, in what fashion, in what pattern, okay, they combine. Okay, so after the combination, to what geometry they have gone, keeping in mind repulsions among the electrons. Which electrons? Electrons already there inside the atom. Okay, so all those matters. That's why once we understand the chemical bonding chapter, then we can say aram say it is because of this reason water has gone for the V shape and carbon dioxide has gone for the linear shape. Okay, so only chemical bonding will give answer for all these questions. Therefore, what I am explaining today, the importance of chemical bonding. Okay, the utility of chemical bonding in understanding chemistry. So chemical bonding is most important chapter. So in this unit we will analyze the various theories and their principles which were developed over the years to explain the nature of chemical bonding. Okay, right. So now, what are those theories? Okay, we will understand those theories now. See, one small sample where sodium cation and the chlorine anion, so they are combining with each other with smile, they are happy. Okay, so only conditions prevails. So if the conditions are supporting, then only they will combine, otherwise they will not combine. So for combinations there are conditions. Why life is there only on the earth? Because of conditions. Conditions are supporting. There are various conditions which are supporting life on earth. So this type of condition or these types of conditions are not there on any planet. Because of the conditions only we are enjoying life on earth beautifully. So here also in chemistry conditions matters a lot. So a chemical bond may be defined as the force of attraction which holds various constituents or entities together in different chemical substances. This I made clear just before few minutes. Bonding involves only the valence electrons. Most important. Bonding involves only the valence electrons because valence electrons are the outermost electrons. See the picture of sodium chloride here. Okay, so the sodium circle you can see, the chlorine circles you can see. It is the valence electrons they are combining first. Okay, inner electrons are very safe. They will be supportive. If any guest is coming, we will welcome. Okay, so like that, so they welcome the guest, but it is the outer electrons. They are playing an important role in going for shake hand. Okay, in welcoming. Okay, so like that, so just these are examples to understand how the chemical bond happens. So it is the outer electrons, it is the valence electrons which are outside around the nucleus. They play key role in chemical bonding and they will combine either by giving or by accepting or by coordinating I by that or by the transform. So some electronic transaction, some electronic mode, some electronic pattern they will do. Ultimately a kind of force exerts between the two ions and they combine, then they make a bond, then they make a molecule, and many compounds are formed today. So millions of compounds are formed because of this what? Because of this chemical bonding attraction between the atoms. Okay, and in the atom, once again, it is the valence electrons which are very important. They take part in the chemical bonding. Yeah. Now, compounds are formed from chemically bound atoms or ions. So when the atoms and ions are chemically bound, then we have the compounds. Otherwise, if they simply mix, then we get what? Mixture. That is the idea behind this statement. Oh, beautiful. Can you see this slide? Anybody?
Yes, sir. Yes,
Very
sir.
good. Very good. So this chart will give us complete picture of chemical bonding and what all theories we have to study. So different scientists they have contributed because of their PhD, because of their research work, and because we cannot study everything, So one person will come, will study one particular topic, and he will go. Because to study that topic, he requires a lot of preparation. Okay, so maybe he has to approach his seniors, friends. Okay, then some books. Okay, some experimental data. So after doing all these a lot of work, maybe it may go to 3 years or 5 years. Sometimes if the topic is very tough or challenging, so it will go to 10 years. So after all that work only, so at last success is achieved, and today we enjoy the chemical bonding because of their contributions. So all these are theories in chemical bonding. Okay, so the very first theory is what? Kozal-Levy's theory. It is what? Kozal-Levy's theory. Then we go to the VSEPR. VSEPR is what? It is a short form. Long form is valence shell electron pair repulsion theory. So in the valence shell, there are pairs of electrons. Those electrons pair will show some kind of repulsions. So keeping the repulsions minimum, we go for the bonding. So that theory we will study in detail. And that is known as what? In short, VSEPR theory. Okay. Then we'll go to what? The theory number 3. That is VBT, valence bond theory. This also will give about the valence electrons only. All the theories will give about the valence electrons. But the only thing is in a different way. In the beginning, science was not developed that much. So whatever available information they have gathered and they have done it. Okay. And as the time progressed, as the time passes, so we get more and more information. So using those information, we go to better theories. Okay. So year by year or decade by decade, we improve upon our science knowledge. So the third is very important, valence bond theory. Most of the questions occur from this area, that is valence bond theory. Nearly 70% questions will come from this area, VBT, valence bond theory. And this theory is given by the famous scientist, what we have seen in the previous chapter, periodic table, last slide, Linus Pauling, American scientist. So his area was what? His area was electronegativity. So in studying electronegativity, he also studied the bonding also. So that's why the contribution of Linus Pauling in this field is very important. When the topic starts, we enjoy VBT, that is valence bond theory, mainly given by Linus Pauling. Other scientists are there, but main contribution is from Linus Pauling. Then we'll go to fourth theory, MOT, molecular orbital theory, better than VBT, because VBT will give almost 90% answers, but some answers to some questions are not given by VBT. So because every theory, every system, they have got some limitations. What we have seen in the structure of atom. So Thomas gave some idea, then he stopped. Then came Goldstein, then came Chadwick, then came Bohr. All those quantum mechanical model, Schrodinger. After Schrodinger, many more scientists have come. Heisenberg, De Broglie. So all those, and at the end we enjoyed structure of atom chapter in the same way. So MOT, that is molecular orbital theory, is better than VBT. Some properties are explained better by MOT, but VBT is we take. To explain MOT, we want the help of VBT. Okay, only some area. In some area, it was not in a position to give the correct explanation. So only that part is explained by the MOT. Otherwise, MOT, VBT both will give the same idea. Then we'll go to the hydrogen bonding theory. Okay. So hydrogen bonding is what? Hydrogen bonding is any molecule, it should contain first hydrogen. Okay. And that hydrogen has got link with what? Most electronegative atom. If these two conditions are there, only those molecules will go for the hydrogen bonding, and that theory is called what? Hydrogen bonding theory. For example, water. In water, we have hydrogen. Okay. So that hydrogen has link with what? Most electronegative oxygen. It is the second most electronegative link is there with the oxygen. That water will go for the hydrogen bonding. Then ammonia, one more example. Okay. So in the ammonia, hydrogen is there. That hydrogen has got link with what? Nitrogen. Again, third most negative. So it is the most electronegative. Usually, starting from the fluorine, top one, fluorine, then oxygen, then nitrogen, to some extent chlorine. Okay. So only these, if they have link with hydrogen in their molecular formula, only those type of molecules will show this theory, this bonding, which is known as what? Hydrogen bonding theory, small theory. Okay. So that also we'll discuss. Then we'll go to what? Excuse me. We'll go to the one more important theory, CFT, crystal field theory. So this theory is a very recent one, and this theory we study not in the 11th class, but I have taken under the chart making. So this theory is there in the syllabus of what? 12th class. Okay. So Kozal-Lewis theory, VSAPR, VBT, MOT, and HBT. All these small theories we learn in 11th class, whereas the only one theory, crystal field theory, we learn in the 12th class. Okay. So we have to wait for the 12th class to understand CFT, because it is very vast. Then we'll go to what? I think I have explained the different theories. Now, what we'll do tomorrow? So tomorrow we'll go what with a new something new, so that we will understand first theory, that is what causal Levy's theory. So now till now whatever I have explained, so I wanted to show the actually it is very, it contains some important videos, but due to some technical problem I am unable to bring that. So let me see.
Share to what?
That one okay. That I'll share to WhatsApp. No, I will only try to learn
Okay.
how to bring to this area, so that for me also it is beneficial. No, so sometimes you are the teacher for me, I am the teacher for you. Tree is a teacher for me. So everyone is a teacher. So nowadays, what our Rohit Kolki told in his speech on the Teachers' Day, that we learn not only in the classrooms, we learn from nature, we learn from parents. Okay, we learn from parents, we learn from small ant, how ants go together in the social network. There's a full line, you can see the entire line, they cooperate, they coordinate. So the coordination, the organization ability of the ants. So everyone is a teacher in this world. So like this I will try, otherwise I will go with a normal PPT, and if possible I can bring, otherwise we'll go with a normal PPT. Now any doubts regarding today's session, a small session about the, just it is a beginning. Okay, so about the beginning introduction, what is a chemical bond and what are the theories. Theories I give only idea. So detail, when the theory starts, we'll understand what is that there in that. Hmm? So till then please wait. Beautiful theories are there with examples. So chemical bonding is
Okay.
very clear. Hmm? Okay. So then anything at
Sir.
all about the chemical? No? Okay. Uh, who told me to share that you have to share something? I was unable to see that name. Who guided me? Is it Ramalinga or Pawan? Who
Rahul.
Rahul? Okay, okay, right. Thank you,
Rahul.
Rahul. Thank you very much. So, for
Rahul sir.
technical assistance, because present generation is very fast. Hmm? So they'll be with technical. They always doing something with the laptop or the electronic gadgets. Okay, so we are matching. We are keeping abreast with the latest technology. So still we have to use a lot of technology in future. So therefore, no problem. So you are there, young generation, young blood. Huh? So we'll make use of all those, because always you remember, it is the technology has won the race. Whether it is war, technology has won. Whether it is medical field, technology has won. Education field, technology. Okay, so along with the good old traditional method, if you can mix the technological method, no. So traditional method with the technological method, that blend is very tasty. Okay, so if you go for the tasty blend with the two tea, one tea is the traditional, one tea is the technological. Let us not leave what we learned from the past. Okay, so our traditions, our methods. So we'll club it. So with that, so we'll go to the technology part. Will that also will be blended, mixed, and ultimately our main aim is to enjoy and to understand. So rote memory or by hearting, all these techniques we don't follow. We 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 go to the clarity of the concepts. We clarify all our doubts. Then we apply in the day-to-day life, and we enjoy. Hmm? So science is developed in this way. So I think uh, from my side, today it is this much. Then from tomorrow we start the first theory, that is causal Levy's theory. So Levy is a scientist. Causal is, there are scientists. So they give brief idea how the electronic structures are drawn using the atomic number and the electronic configuration. So that is the only idea given by the causal Lewis theory. So we learn with examples in our forthcoming session. Okay. So till then, I think I will wind up the this what small session, and tomorrow with the full zeal and with the fresh mood, with the different slides with examples, we will continue our journey, because the chemical bonding is slightly a bigger chapter, like structure of atom. So first and the third are very small. Now second and fourth are very big. So we have to learn many theories here. So it will take some time, but no problem. So we'll understand every bit of the chemical bonding, because this chemical bonding is very important for the next year, 12th class. Okay. So till then, if you have got time, just keep thinking, and at the
Okay,
same time
sir.
take care also. And let's come once again all together tomorrow, the Ramalinga team, and we will enjoy. So till then, thank you, one and all.
Thank you, sir.
Thank you. Thank you.